Quantum theory, which predicts that the future might be influencing the past. One of the weird aspects of quantum mechanics could be explained by an equally weird idea that questions can run backwards in time as well as forwards. What Einstein called spooky action at a distance could theoretically be evidence of retrocausality, which is particle equivalent of getting a stomachache today thanks to tomorrow's bad lunch. A pair of physicists from US and Canada took a closer look at some basic assumptions in quantum theory and decided unless we discovered time necessarily ran one way, measurement made to a particle cloud echo back in time as well as forward. We all know quantum mechanics is weird, and part of that weirdness comes down to the fact that at a fundamental level, particles don't act like solid billiard balls rolling down a table, but rather like a blueberry cloud of possibilities shifting around the room. This blurry cloud comes into sharp focuses when we try to measure particles, meaning we can only ever see a white ball hitting a black ball, one into the corner pocket, and never continuously white ball hitting black ball into every pocket. There is an argument among physicists over whether that cloud of maybes represents something real or if it's just a convenient representation. A physicist by the name Price claimed back in 2012 that if the strange probabilities behind quantum states reflect something real, and if nothing restricts them to one direction, the black ball in that cloud of maybes could theoretically roll out of the pockets and knock the white ball. Critics object that there is complete time symmetry in classical physics and yet not apparent retrocausality. Why should the quantum world be any different? Price wrote, perhaps the thoughts of most physicists. Matthew S. Leifer from Chapman University in California and Matthew F. Pussy from Perimeter Institute for Theoretical Physics in Ontario also wondered if the quantum world might be different when it comes to time. The pair exchanged some of Price's assumptions and applied their new model to something called Bell's theorem, which is a big deal in this whole spooky action at a distance business. John Stuart Bell said that the weird things that happen in quantum mechanics can't ever be explained by actions taking place nearby. It is as if nothing is causing the multitude of billiard balls to take such weird parts at fundamental level. The universe is random. But what about actions taking place somewhere else or somewhere else? Can something far away influence that cloud without touching it in a way that Einstein called spooky? Two particles are connected in space at some point, measuring the property of one of them instantly sets the value for other, no matter where in the universe it has moved to. The entanglement has been tested over and over again in light of Bell's theorem, plugging loopholes that might show they are really interacting on a local level in some way in spite of what seems to be a distance. As you might guess, the universe still seems pretty spooky. But if causality runs backwards, it would mean a particle could carry the action of its measurement back in the time to when it is entangled, affecting its partner. No faster than light messages needed. There is a small group of physicists and philosophers that think this idea is worth pursuing. Leifer told Lisa Zegai's physics organization by reformulating a few basic assumptions. The researcher developed a model based on Bell's theorem where space were solved for time by their recognizing unless we can show why time must always tick forward, we run into some contradiction. Needless to say, the idea of retrocausality is a fringe idea. Now keep in mind, this kind of backward time travel isn't the sort that would allow you to go back in time and change the present. Sorry to say, future scientists also won't be able to encode lottery numbers into entangled electrons and mail them back to their younger selves. In any case, the idea of anything trickling backward in time might not be an appealing one, but let's face it, when it comes to phenomena like entanglement, nearly any explanation is going to sound downright insane. This research was published by a proceeding of the Royal Society.